Good afternoon. Welcome to another episode of Garrett's Garage. I'm going to step away from the Forerunner series for just one video. I've got to do some fill-in work that's not really going to be worth filming, just some finished welding and miscellaneous fit up. So instead, I'm going to be introducing my horizontal bandsaw and some of the modifications that I've done to make this a more useful tool for me.
Alright, so this is my Jet brand 4" by 6" horizontal metal cutting bandsaw. One second. Alright, that is much more presentable. So out of the box, these saws are great, but I'm hoping to show you just a few modifications that can make them work even better for you. First and foremost, one of the most critical upgrades is going to be making a suitable frame, something that has more rigidity than the stock sheet metal frame that they come with, as well as extending a little bit farther out the back so when you stand it upright it doesn't tip over backwards. Also went and added an aluminum chip tray to try to catch all of the cut-off remnants and the dust that's going to be produced by the saw. That's fastened by just a couple Allen head screws here on the bottom, so it's easily cleaned out. I've also grabbed myself what's called a sewing light. It's a plug-in 12-volt magnetic light that has a bendy arm on it, so you can position it to look at your work, line up your cut marks. It's a cheap and very effective light to add to one of these saws. I actually have them added to most of my tools. The next modification I did was cut some custom mounting jaws. So all I had to do here was cut down some 1/4" plate, put some screw holes in it, and then tap the same screw holes on the stock mounting jaws to mount them. This is going to allow you to extend those jaws closer to the blade, which will allow you to grab much smaller material stock. And let's be honest, if we're going to be OCD, it looks way better to have two jaws that are the exact same size and fit up this nicely. The next modification here was adding a secondary screw threaded through the backside of one of the jaws. This allows you to thread that screw in to apply equal pressure to the opposite side of that jaw, keeping it from spinning, allowing you to get a tight grip on a small piece of stock mounted out at the edges of those jaws. Typically, I know you would just use a similar diameter material on the opposite side of the jaw to even out that pressure, but if you're ever in a position where you have a unique part or you're trying to cut down, this alleviates you trying to cut a custom spacer or do any extra work that isn't needed. And finally, this is probably the most important upgrade that one of these saws could get. This is a hydraulic lowering cylinder. These saws typically come from the box with a lowering spring that mounts on this drop arm and back here at this hole in the frame. The spring doesn't apply the proper tension that's required to minutely adjust the downward pressure of the saw depending on different thicknesses of materials that are being cut. A lot of higher end saws, typically larger saws, are going to come with some sort of a hydraulic lowering system pre-installed. And they do sell pre-made kits for these horizontal bandsaws that you can buy. However, if you're a maker like me and you want to make your own, it's not a complex system and it's going to drastically improve the amount of control, blade life, and quality of cut that you're going to get out of these smaller, cheaper machines. Here's a little example of how that hydraulic assist works. The black valve you see down here on the bottom is going to be the speed controller. If you run that all the way in, it'll hold the saw in whatever position you want to leave it. And then you'll have minute adjustments in and out to speed up or slow down the lowering of the saw body itself. The gauge you see up on the top left is just a pressure gauge that's teed into the body of the cylinder. That's going to give you a numerical value that's associated with the pressure that the blade is applying to the material that you're cutting. For me, I found that 100 psi is a good compromise between a decent cut speed while still preserving blade life and keeping the pressure low enough to prevent the blade from wandering off of a square cut. Here's a little example of how that speed control looks on the actual saw. If you run that out, it's going to speed up the dropping of the head, and if you turn it back in, it's going to slow it down. Infinite speed control. So these systems are comprised of very few parts. So the main body here, this is actually an air cylinder that I got offline. I can link that below. And then I just got two Heim joints that are, this one was sized for the threads that fit onto the shaft here.
And this Heim joint was sized for the bolt to fit through the hole that already existed on this end. This is bolted through the frame that the saw is mounted to. I just welded a bung onto here and threaded it for this end to mount to. This end, I was able to drill out the existing arm where the spring originally mounted and put the cylinder, the rod end of the cylinder mounted through this arm. That provides you the cantilever effect that gives the cylinder mechanical advantage to push against the downward force of the saw. Down here, all you've got is your in and your out of the cylinder, and then a T. The T isn't 100% necessary. You don't have to run a gauge, but I'll talk a little bit more later here as to why the gauge is useful. But the key mechanism here is this is a check valve with a knob on it that allows you to restrict fluid flow. I'll try to find a link for the one that I bought of this as well. I think this is also a pneumatic fluid valve. But essentially, the knob allows you to restrict flow in one direction. So I can lift it up full speed and it'll bypass the valve. But then when I let it back down, however I have the knob set will restrict how slow the saw descends. Which in this case, the way a cylinder works is at the end of this rod, there's a like a piston inside this body with a seal on it, and it tries to take the fluid. In this instance, the rod's trying to go out, which means it's trying to push the fluid out of the end of this cylinder, and we want to reroute it back to this side because this is a system that doesn't have a reservoir. So as the fluid gets pushed out of this end, it gets rerouted to this T. This line dead ends at the gauge, and then this side reroutes through the check valve and then back into the bottom side of the cylinder. So you want to make sure that that's oriented correctly, otherwise this won't work. The gauge is just a pretty standard 0 to 200 PSI analog hydraulic gauge. Or actually, it might even be an air compressor gauge. A lot of the stuff I'm using on this is just pneumatic stuff because it's cheaper. And it's working within the pressure ranges that we're looking for. So mounting it the way that I have it, utilizing the existing lever point, the max PSI that you're gonna see in like the horizontal stagnant position, similar to like your lowest point, is gonna be 150 PSI. So the 0 to 200 PSI is really a perfect gauge range. That's important because it's going to tell you what your downward pressure is, which in turn is how much force the blade is applying to your material. You're going to want to adjust the valve so that, I mean, it's going to be a saw specific, I'm sure, but for the blades that I'm running to cut carbon steel most of the time, I try to keep the saw pressure to around 100 PSI on the gauge. That is a pretty slow speed. It's typically just going to be 3 clicks out on the gauge, and you probably can barely even see that saw coming down.
If anyone's interested in piecing together their own kit to do this same modification, these are the parts that I used. The first, for the hydraulic cylinder, this was purchased through Automation Direct. The part number is on the screen. The next item is going to be the hydraulic valve. This is an Ingersoll Rand ARO part number. This is a Grainger listing, but it can be found cheaper through Zorro or eBay. The next 2 items are the rod ends. These were also purchased through eBay. The 7/16 right-hand thread goes onto the end of the hydraulic cylinder rod. The smaller rod end bolts through the lower end of the hydraulic cylinder. And the remainder of the parts are just standard brake line, tube nuts, and different adapters to make all of the connections that you're going to need, as well as some T-fittings and right angles to make sure that you're routing everything the way that's going to keep it safe and function properly. Huge thank you to the 3 of you who stuck around to the end of the video. If you like this sort of thing, please like and subscribe. And if you modify your own tools, maybe comment below and let me know what you're working on. My name is Austin, this is Garrett Garage, and stay tuned for the next video to see what sort of modifications I'm going to keep doing on this saw. I've got two little mods that I got in mind that didn't fit in this video, so I will be back with more bandsaw action.